All right, so we're going to design a part. Well, we're going to copy the design of a part. We're going to model it on paper, and then we're going to model it in CAD, and then we're going to 3D print it, okay? Its PLA filament will be capable of withstanding whatever forces come its way, considering it's a piece of a bed frame. Subscribe and like the video. A structural piece. We should adjust the parameters for the thickness to be essentially like 100%. Alright, go ahead and pull a measurement on this bad boy right here. Pull it in inches. We could work in centimeters here now. I think it'd be a little more accurate. You know, I could really use a light right now. That's my. Yeah, I'm gonna call it 16. And that'd be what? So that's 1.6 centimeters. 16 millimeters, yeah. So 16 millimeter. 16 millimeters all around on that side. 2.4, 24 millimeters. .24 millimeter. Alright, if you're looking at the shape like this. 2 millimeters. Oh, yeah, that's all I need then. Okay, and then the circle, which we'll have to find the center of. Shit, man, it's all over the place. Yeah, whatever, something like that, I don't know. I reckon that's good enough, huh? Let's try that. 1.5, call it. 1.5. Sure, let's do it. 1.5. 15. Okay. Alright, here we are to the modeling station, so let's begin. Features, extrude boss base, we're going to choose a plane. Top plane, we're going to work upward. Top plane. So I'm going to start with just this guy. Alright, we're going to smart dimension it. We want 16 by 16 millimeters. It's in inches, so we have to specify. There it is, 16, smart dimension. 16 millimeters. There it is, okay. Now we can center this up by, wait, not 0.8, but 8 millimeters. Yeah, those 16. Yeah. There we go, check. Alright, there's that. We pop that up, and we bevel that after. Yeah. Alright, now we're going to do an extrusion, and we're going to extrude this 2 millimeters. Bang, bang. Now we're going to do another extrude boss base. We're going to choose this face. We're going to put another square. Oh, did I not? Hold on. I got to change. Yeah. Exit sketch. Here we go. Edit sketch. Smart dimension. There we go. Okay. Exit sketch. Extrude boss base. Now choose the face. Okay, now we're symmetrical as needed. Now we put another square. Smart dimensions. This one is Oh, we actually didn't measure that. That was forgot. I forgot that. Okay. Alright, jumping back to here. It's looking like a good... one 12 millimeters. A good 12 millimeters. So we can draw that out. That's from the bottom. $12 millimeters. We could do 12 millimeters, and then then there's that guy. Yeah, good enough. 12 millimeters, 12 millimeters. And then we could even, like, to represent the hole, we could do like that. I don't know. Why not? Alright. Okay, so 12. Yep. Whoa. What did I do? What? 12. 16. What is it? 12? 6. There it is. Okay. That's it, really? Yeah, I guess that looks pretty similar. Okay. I mean, my dimensions are correct. I mean, what am I gonna do? Alright, 24 millimeters. Alright. Holy smokes. Okay, look at our part for reference. What is this number? What the? There's a huge number on my screen. Oh, wow. Oh, I should totally hide that for now. Totally should have got rid of the chat thing for the video. Oh well. No problem. But check this out. Here's our part, right? Okay. There's our part, and here's what we have so far. Now remember, we're going to add our bevels, but they're not incredibly important, so perhaps we'll overshoot to make sure that we don't have too much material and that our object fits. But truly, the bevels do not need a high level of precision. Okay, but that's all looking good. We have everything dimensioned correctly. That's good. Now we can add our hole. We can do an extrude cut, choose any face because we have a symmetrical object. Add that. We're going to center him up, which is 6. And from the center, correct 15. 15. There we go, check. I have not measured the diameter, so let's choose that. Six millimeters. But if you look, was I showing you or not? No, because I wasn't showing it. I wonder what part I was showing, because I think I just switched it. So here, right here, right here. See, they're not creating those diamonds at the corners though. It's a little bit different. That's gonna be my only, well, perhaps it's a problem with my geometry, rather. It is, it's a problem with my geometry. This should do it though. No, I feel as though the head needs to be different. It just needs to be a little bit bigger. I know it. So we did 16? Yeah, we did 16. Let's make it 18. Oh, come on. 9mm. Bang. Alright, that's perfect. Exit sketch. Updating, and it should be good. Alright. Getting it together. To make it exactly like it. That would be sick if I made it exactly like it though. So let's do it. Let's do an extrude cut. And 45. Yeah, that's what we want. No. Now that's dependent upon how much I'm cutting off. And that would be, wait, so that's, ooh. Oh, that was even less. Alright, whatever, that's it. Okay, that's pretty much what I want. Now I want to try to add a mirror, no, not mirror, linear sketch pattern with respect to this. Oh, yeah, I mean, that's... Wait, that's it. But I gotta finish this now. I gotta make it a complete shape so I can extrude it. Okay, there. Check. Nope. Yep. That. Parameters. Wait a second. Over defined? Why? What? Whoa. guess well, because it's not really doing. I guess it is. Okay. Alright, it is working as a sketch. I don't know, for whatever reason. Parameters? No. No, parameters. This guy. It's already there. Alright, fine. This line, this line. Bang, 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 bang. There it is. That's what I want. I want to exit sketch and I want to extrude these guys. Yes. Cut, extrude, bang, just like that. That's perfect. Okay, now we can do a fillet. To all, did everything? It did everything. To all of these guys. Let's decrease it a little bit though. There it is. Not quite. Let's go back to 0.04. That's better. There. And that's our part. Take a look here. We'll run it back one more time. Flip it around so you can kind of see the light reflect on all those bevels and those different geometries. Here's the hole. The hole itself got the fillets on it too with an inner and outer diameter. You can see that the transition between this fillet on the edge of the long rectangular piece connects is coincident with the outer edge of this fillet for the hole. Okay, there's really not much space in between, and you'll see that our model is representative of this as well. Look back here. Look at the space that we have between the two. I pulled rough dimensions, you know, just with this protractor, but it's like works. That's pretty much it. So now let's okay, so save as. Let's get this one saved. Rack and pinion, SolidWorks. Let's take it to projects. Bed piece. Connector. Okay, let's see what this is. Polygon now. We have the exact shape that we need. Check. Alright, let's do a smart dimension. I haven't really worked with the polygons yet though. Now we can choose the diameter. So that's from edge to edge. And that's looking like 9 millimeters. Take a look here. Check this out. We got what's looking like 9 millimeters. Alright. And that physically looks correct. Well, that would be ideal though. It'd be ideal to rotate it so that those edges are flat. Okay. How do we do that though? Let's see. So we want to keep that guy. We like him. I want to, I don't know, I guess a center line. Whoa, what the? Wait, did it work? Oh. Shit. Alright, I don't know. I'm not. I mean, it's pretty good actually if it will stay right there. That's fine. Yeah, that's all fine. Alright, now we're only going to extrude cut a certain amount, so blind it, and we want to go pretty much just the depth of this guy, and a little more, I guess. So he's looking like 4 millimeters. 4 millimeters. Alright, fantastic. 4mm, should we add a little bit? 5mm, give him a little bit of depth. Yeah, definitely. Check. Alright, now we have a slot for that guy. Oh. That's what I needed. Do this, now I need to do this, now I need to do this. Oh my gosh, look at that. We got it. Ladies and gentlemen, we got it. Side though. It didn't stay up. 90. Infill. Density 20%. Now I want this to be, let's see how long it takes with 100% for one. And then support structure, generate support. Don't do that. Travel. 45 retraction speed. Z hop when retracted. Enable retraction. Retraction speed. Okay. Print speed 140 milliseconds. I don't know, maybe that's crazy. Let's turn that down. It wouldn't be that way for no reason. Or what if that's nominal though? Print temperature 22, 223. That's no, that's pretty high. That's good. Yeah, and 70, that's great. Mesh fix, dual extrusion, build plate. Okay. Let's see how long that would take. 38 minutes. That's gonna be like 2 hours. For 3 hours. We should preview it. Gonna look like that when it's finished. It's gonna be 100% filled in. Let's see that. Wow. Should be strong. Should be strong enough. All right. Okay, and we're back. I found it. This is what I was looking for. All right, this piece here. We have the chip and the thing. Let's put this in our computer and we'll transfer it over. Here we go. There we go. Now I got it. Eject. Alright, we need to severely clean this guy. Okay, it's been too long since we've used him. Let's, I need to get some cleaning tools. right? So day 2, I mean, it didn't take that long. It was like a 3-hour print, but I was already concluding my day, and so we finished there. As you can see, we got it sitting here on the 3D printer. And I printed a bunch more, but I saved this moment for you guys so that you could see. All right, we pulled that off. We're gonna transition back to over here. All right, so this is the final product. I did intentionally design this head to be a little bit larger than the original head, right? And we put a slot for the nut because this hole here is threaded. And now I'm not actually, you know, as much as I don't want to admit, I'm actually not capable of making threads in SolidWorks yet in CAD. I can do it in Blender as I've done it before, but I'm not capable of doing it in CAD yet. I'm sure it's a very small learning curve. Like, I will figure this out in a couple hours. But until then, I didn't want to waste any time trying to get this done. So I just decided to do an alternative, which I will show you right now. This was my method. So I created this slot, but the slot is slightly too small, right? Because I made it to exact dimensions. I should have added a little bit of tolerance, but I didn't. But that's okay, because now we're going to get a very snug fit through the use of, what would be the right term for this? I know there's a name for this process, but I just don't remember. Like heat inserting, something like this. But this is what we're going to do. So let me just get my things lined up here. I do kind of want a bit of a higher platform that I can set this up against so that we can lean him off of there. And that should do it. Let me do it right here. Can you see that well? That should be fine though. And just like that. Alright, so we'll heat this guy up. Whoops. Actually, I don't know that I did specify. I think I did in the beginning of the video. But the purpose, I don't know if I specified the purpose of this, you know, part. But it's to, you know, it's a piece. It's fulfilling a piece that's gone missing. That is one piece in a large bed set. You know, for a bed frame, you build the bed frame. You can only order, you know, the set. So it's not like you can order individual pieces or perhaps even find them anywhere. Right, this is the original piece, and so we went ahead and modeled it in CAD, and then we built it here. We 3D printed it, and then here we are, right? And so I'm compensating for not doing the threads in the piece itself, which, like, I have an Ender 3. It's like one of the most basic 3D printers on the market. It's been very good to me, you know. So I guess I would recommend it for a beginner, but ultimately it's not the greatest hardware, and so to try to print a fine thread. Which in here actually would be doable, but it's just because it's not that fine of a thread. I know we can't really see it. It's not that fine of a thread, but granted, it's still like to try to achieve perfection by 3D printing this thread would just be an absolute, it'd be a stressful situation. It'd probably rage bait we're just going to avoid it altogether. And we did. We did our own thing, right? We made this modification here, and as you can see, I already got, 3 more of these, right? So we can take this out. And now, instead of using the original bolt, right, we'll use it for this single one that we have, considering we do still have the bolts. We'll just use these bolts now, and if I need to get longer ones, I should be able to get longer ones with this, the same thread count and the same, you know, grade. So I think that'll work out well, right? Now this is the one we just recently did, and we go through here, just like that. Right, so that's the conclusion to this piece, to these parts. Right, this was the original part that we imitated. And as you can see here, we got them all together. Thank you for joining me, and please look out for more. You know, I stream a lot, and I'm looking to make more videos. We have a lot in progress, so keep an eye out, subscribe, and like the video. I appreciate you guys.